blow molding process for the production of hollow articles was early recognized as a natural application for an extrusion machine. But the problem was matching an intermittently operating blow molding machine to a continuously operating extruder. Initial attempts resulted in slow paraffin delivery. Since uniform wall products require fast paraffin delivery, first attempts led to attaching a pot-type accumulator to the extruder. Extruders could now operate continuously, and material could move across and out of the dies at a high rate of speed. In these facilities at F.J. Stokes, researchers recognized the disadvantages of the accumulator. The plunger was a source of leakage, scuffing of the material caused streaking in the end product, the accumulator was difficult to clean, color changes were impractical, and the extruder thrust bearings were subject to heavy loads. This is the newest in the Stokes line of blow molding equipment, encompassing a unique reciprocating screw extruder, a dual manifold equipped with dual paraffins for each end of the crosshead, and a two-station 2.5-ton clamp press section. Through pioneering efforts in injection molding, Stokes has developed a reciprocating screw which is an ideal solution to the blow molding extrusion problem. Because the system is in line, there's no point of hang-up, and purging or changing from one color to another is simply and easily done. Designed as an integrated unit, this team assures high production at a minimum investment. Only one of the many blow molding teams currently available from Stokes. Let us take a trip along with a scoop of linear polyethylene from a shipping bag to the finished quart container. The material in the hopper is normally at room temperature. The plastic granules are fed to the screw, which carries them through the heated barrel where the pellets reach the viscous state. The engineering roadmap illustrates the movement of the granules. Material temperatures are controlled by the heating bands on the cylinder and by the speed of rotation of the screw. For the extrusion of different types of materials, various screw designs are available. As the screw turns, the material is forced toward the right end of the barrel. Since the material cannot go past the rotary valve shown at the front end of the barrel, the screw itself is forced to move to the left, thereby pushing the shooting cylinder to the rear. When the screw is in its fully retracted position, the rotary valve opens a port into one arm of the dual manifold. Immediately, the shooting cylinder rams the screw forward, forcing the heated plastic through the crosshead where it is extruded. Since the extruded tube tends to neck down from gravity, the paraffin must be produced as rapidly as possible. As soon as the paraffin is delivered, the mold closes and the tube is inflated with air until it conforms to the chilled mold. During the cooling time, the flow of plastic from the extruder is automatically delivered to the other manifold. After cooling, the mold opens and the parts are ejected either manually or automatically. Just ahead of the shooting cylinder on the left is the hydraulic motor and gearbox which drives the rotation of the screw. The gearbox has a splined hollow shaft to permit the screw to reciprocate through the gearbox. The actuator assembly demonstrates the action of the rotary valve. When the valve is centered and both of the ports to the manifold are blocked, no plastic materials can flow through the valve, and any extrusion that takes place forces the screw to the rear. Now the rotary actuator turns and the left port into the crosshead is open. The screw is reciprocated forward and material surges through the valve and manifold to the crosshead. To maintain uniform flow, an additional valve is placed in each of the crossheads. Material flows through the second valve and around the mandrel to the tips and die at the rate of 1,200 pounds per hour, or 1 pound in 3 seconds with this team. Here, the left-hand mold opens and finished bottles are removed. Now the valve rotates and the paraffin is delivered. The mold clamps shut and cooling begins. With the valve in a neutral position, the reciprocating screw returns to its full charge position. The extruder valve shifts, and plastic material is delivered to the right-hand mold. At the closing of the mold over the parazine, the screw again recharges. Our scoopful of plastic granules required approximately 48 seconds to travel from the feed hopper to the front end of the barrel, where the homogeneous material was extruded through the manifold. Had the granules been colored, a color change would now be apparent. Notice the small variation that exists between the two parazines as they're extruded from the crossheads. This is an excellent indication of the consistency and uniformity of the plasticized material. The easily accessible control instrumentation and the complete absence of a separate drive unit or belts are outstanding features of this Stokes blow molding plant. Temperature control instruments are mounted on the frame of the machine with special attention paid to shock mounting. The pump motor is on the right, and the panel-mounted valves for the control of the rotation and reciprocating of the screw are in the center. The pressure gauge is provided with a shutoff valve. An ammeter. All are standard equipment. When removing the screw for the extrusion of different materials, it is only necessary to swing the crosshead aside and push out the screw with the hydraulic cylinder. On the reciprocating shaft, a special rotary joint permits water cooling of the screw. Readily apparent is the open construction of the Stokes blow molder for the fast removal of blow molded parts. No tie bars clutter the front of the mold, and the bottom area of the machine is completely open to accommodate conveyors for part removal. Complete flexibility of automatic or manual operation is provided on the centrally mounted control. As an illustration of the effectiveness of the inline accumulator, we're demonstrating the standard rate of extrusion from a 2.5-inch extruder. Now observe what the reciprocating screw extruder adds to blow molding production. Rapid parazine delivery reduces necking down, thus improving product quality and reducing mold open time. Inline construction has eliminated the need for thrust bearings, and with this new Stokes unit, all of the advantages of an accumulator without the disadvantages are available through the unimpeded linear flow of plasticized material. The self-purging feature of the reciprocating screw is a real plus. Note the many blow-molded items made from polyethylene, polyvinyl chloride, polypropylene, and other materials. There's a Stokes blow molding team ideally suited for handling these materials for various industrial, toy, and houseware markets. Ask which team best fits your needs.